We want to look at properties of the preferred or indifferent relation defined on the consumption set X. So we want to look at properties of the preferred or indifferent relation defined on the consumption set defined on the consumption set X. So let's start with completeness. Number one, we're going to look at completeness. Now, completeness says that the preferred or indifferent relation on X is complete if for all X and Y that belong to X. So this means for all, right? So this means for all. If for all X and Y that belong to X, now it is said to be complete if X is preferred or indifferent to Y, or Y is preferred or indifferent to X, or both. Which essentially means that either X would be strictly preferred to Y, or Y would be strictly preferred to X, or you would be indifferent between X and Y. So complete means the preferred or indifferent to relation on X is complete if for all X and Y that belong to X, either you have the case that X is preferred or indifferent to Y, or you have Y is preferred or indifferent to X, or both. If you just have X is preferred or indifferent to Y, then that essentially means X is strictly preferred to Y. If you just have that Y is preferred or indifferent to X, then that just means the Y is strictly preferred to X. If you have both, then that means that X is indifferent to Y, right? So either X is strictly preferred to Y is strictly preferred to X, or indifferent between. So this is what we mean when we say the preferred or indifferent relation on X is complete. Essentially, it means basically, it implies that the individual is able to rank all bundles. You can either tell whether one bundle is better than the other, or it's at least as good as the one bundle. This implies that the individual is able to rank all bundles. Right? And there is, in terms of ICs, this means there is some IC when we draw the indifference curve. So there is some ICs for indifference curve passing through every bundle in the consumption set, right? So this is the implication of this. In terms of ICs, implication is that there's some IC passing through every bundle in the consumption set once we make the IC in the consumption set. Right, so the first property you looked at, what does it mean when we say the preferred or indifferent relation is complete on a consumption set X? And then we looked at what it implies and in terms of the IC as well. Like you'll always have some indifference curve passing through every bundle in the consumption set. Now, this was the first property of the preferred or indifferent relation defined on the consumption set X. Now, let's look at the second property, which is transitivity. So let's just erase this out. Now let's look at the second property, which is transitivity. Okay. Now, the preferred or indifferent to relation on the consumption set X is transitive. If X is preferred or indifferent to Y, and Y is preferred or indifferent to Z, then X is preferred or indifferent to Z. So let's just do it. Let's use a symbol for all X, Y, Z that belong to X. And like mentioned, this means for all. Now, what does this imply? Now, transitivity means that if X is preferred or indifferent to Y and Y is preferred or indifferent to Z, then X is preferred or indifferent to Z. This implies that the individual's preferences are consistent. Implies that the individual's preferences are consistent, right? And what does this imply in terms of IC? So if you have an IC representing transitive preferences, what would it imply for that? This means an individual's, in terms of ICs, this implies an individual's ICs don't intersect each other given transitive. So if you have transitive preferences, so ICs for such preferences would be such that they don't intersect each other. So an individual's ICs don't intersect each other given transitive preferences. So this is what transitive preferences imply in terms of ICs, that you will not have ICs that intersect each other. So we've looked at what does it mean when we say the preferred to indifferent relation is complete, and what does it mean when we say it is transitive, and what do each of these imply in terms of ICs, indifference curves.